Okay, so in our gas laws, this ideal gas law worksheet, they have a lot of different variations of the equation there. I really would rather not use those. I'd rather use the equation the same way all the time and just let us just worry about it, manipulating it. But it does give you a little background here, and so that does help. Remember, we're dealing with four variables: moles, pressure, volume, and temperature. So in the ideal gas law, like I said earlier, there's no change being made. I have a balloon, I have a tank. They're going to give us three of the variables, and it's our job to figure out what the remaining one is, the one that's missing. And that's all this is about. Um, we're also going to get into something that's called the ideal gas law constant, this value of R. And the ideal gas law constant is a number that makes the equation work. Okay, without it, it wouldn't work. Mathematically speaking, it wouldn't occur. So the deal with the ideal gas law, though, is there's several different versions of it. So you can see down here on your periodic table that you're going to have for the test and the benchmark, they have three different gas law constants. So as I zoom in here, you can see them. They all have liters, moles, and kelvins. Liters, moles, kelvins, liters, moles, kelvins. Every one of them deals with liters, moles, and kelvins. The only difference between them all is the pressure. And so instead of changing the pressure to fit, what I'd rather do is just find out whichever pressure is occurring. I will use that gas law. So if my pressure is in atmospheres, I'll use the 0.821. If my gas law is in kPa's, I'll use 8.31. If my gas law is in millimeters of mercury or torr, I'm going to use the 62.4. So that's what we'll decide. It depends upon the pressure. So we're going to go ahead and go through number one as an example. I'll zoom back out here. Yes, the paper I gave you is where I want you doing the work. So as I read through this, because it's not always going to tell you using the ideal gas law, sometimes we have to have to decide that. I'm going to go ahead and read through this and start identifying things. A tank contains 115 moles. That's one of my four variables. It has a pressure of 57 atmospheres. That's a second variable. And a temperature. So I have my temperature, and it asks me to find my question mark, the volume. So I know it's the ideal gas law because there's not a V1 or a V2. There's not a P1 or a P2. It's just one of everything. And the only way to deal with that is the ideal gas law. And so since I know it's the ideal gas law, I'm going to go ahead and write the equation. PV equals nRT. That's the gas law that you're going to use. That gas law also can be found in our blue chart right here, PV equals nRT. So there's nothing that you have to memorize. And so there's a couple different ways to try to do this. Some of you are just going to want to jump in and start plugging in numbers. I would rather take a little bit more methodical approach. I know that I have to have P, V, N, R, and T. I actually have I have four variables and one constant. And all I'm going to do is read through this and take care of them. So a tank contains 115 moles. I know that N stands for moles, so I'm going to have 115 moles. M's already taken it for meters, so I'm sure there's a specific reason for it, but I don't have a really good answer on that. It tells me here I have a pressure of 57 atmospheres. Make sure we continue to write down units. It doesn't take you any longer to write 57 ATM than it does to write 57. Okay? It's make some good habits. I read here a temperature of 45 degrees Celsius. That should set off an alarm because we don't deal in Celsius, we deal in what? Kelvin. So right away, I want to change that. So take 45 and add 273. And what do we get? 318. I want to do that right away. I don't want to wait. If I wait, I'm going to forget. So it's 318K. And it says to calculate the volume. That was my question mark. So I'm going to put a question mark here. So, but where am I going to get the R value from? I'm going to look at this periodic table and I'm going to look at the pressure. The pressure we have is in ATMs. So I'm going to find my R constant, my gas constant R, that deals with ATMs. This one has ATMs in it. So this is the number I'm going to use. So my gas constant is 0.0821. And I'm going to write down the units. Nobody likes it to do it because it's a lot. But I'm going to write them down anyway because it helps me solve the problem. If I've done that, I really don't need to go back and look at the word problem anymore. I've got everything I need. So all I want to do now is take this and start plugging it into my equation. So pressure, I have 57 ATMs. I'm trying to find the volume, V. My N is 115 moles. My R value we already found, 0.0821 liters, atmospheres, moles, kelvins. And my temperature, 318K. Let me slide that over a little bit. So, I know we don't like dealing with units. Most of you don't. Let's get rid of some of these. So, in my gas constant, I want to make sure they all match up. Atmospheres and atmospheres, so I can cross them out. I have moles and moles. I have kelvins and I have kelvins. So this is what my answer is going to be. My answer is going to be in units of liters, right? So we're looking pretty good. The next thing that I think for most of us that are more challenged with math is let's just simplify things. Let's multiply everything out that we need to multiply. So I'm going to go ahead and bring this down. 57 times V equals, and somebody multiply 115 times 0.0821 times 318. 3002.3. Okay. And I've still got my liters yet, right? So all I did was just simplify things. Sometimes just seeing that makes it a little easier to do. Still have to get V by itself. Right, if we do the opposite operation, so if they're being multiplied, we divide both sides by 57. So that my 57 cancels out, and I know that V equals 52.67 somewhere around there, 52.67 liters. Okay. I think the ideal gas law is a little easier to deal with once you get over the R, trying to figure out what R you're going to use. So again, identify that you're using the ideal gas law, write it down, pull out all your numbers out of your word problem, plug them in, simplify the math, and come up with the answers. That's all that you really have to do. Okay? Questions? So, what I want you to do today is you're going to do 2, 3, and 4. On on number 3, it tells you to determine the temperature. I don't want you to change it back into Celsius. We'll just leave it in kelvins. Make life a little simpler. Number 4, I don't want to change it to PSIs. Let's just leave it in ATMs for now. Okay? Just get a little easy practice going.